exception handling in Python. So now we'll first try and understand what do you mean by exception, what are exceptions, and then how do we go about handling exceptions. We'll first see how Java handles exception, and then later, sorry, how Python handles exception, and later on we'll see how exactly can we go about handling exceptions on our own. Okay, we'll get started with a very simple, very basic program. Now, suppose you have this program. Write a program to read 3 integers and calculate this. D is equal to A plus B div C. So over here, I just want to write a very simple program from where I'll read 3 integers A, B, and C, and then I'll calculate D like this using this formula. So if somebody is asking me to write this particular code, my code is going to be pretty straightforward. What I'm going to do is I'm going to write enter 2 numbers. I've accepted these 3 numbers and then, sorry, it has to be enter 3 numbers, and then I'll calculate this, and then whatever is the answer that I'll now display. Now what you'll do is in 2 minutes, you'll first type this program, get the output, and then looking at that output, I'll then start demonstrating what exactly is happening, and then we'll define what do you mean by an exception. Let's type this quickly. Please get the outputs. See. Now when I'm executing this program, when I'm writing the values, say 5, 7, and 6, so this was 5 plus 7 div 6, and I get this value 2, and all is working fine. Absolutely no issues with this program. But look what happens now. Over here, the values that I now give is, suppose the value of A given is 5, the value of B given is 7, and the value of C given is 0. So this now statement becomes, this is 5 plus 7 div 0. Now, moment this denominator becomes 0, this division operation is not performed, this division operator is not defined, and that is why this statement will start generating an error, and my program got stuck up over there. Now, observe this, exactly what is happening out here. Now, in this program, when I was running this program, what we saw is if I keep giving values properly, say, so this program keeps working fine. The only possible scenario where this program gets stuck up is if I give my third value as 0. So the value of variable C becomes 0. Now that is where my program generates an error like what you see on the right hand side. So over here, I have a program which genuinely works fine, which is proper, but for a certain value of C, but for a certain scenario, this program, which otherwise is working fine, is now stuck. Now this is what is called as an exception. So understand what exactly is an exception. Exceptions are basically runtime errors. These are the errors which are generated when the program is under execution. Now, please understand, every exception that we talk about is a runtime error, but every runtime error is not an exception. See, generally, if at all, say, suppose I had made some mistake in this program, suppose say I had forgotten to put this bracket. In that case, now this system will give me an error. See, it is giving me an error. It says invalid syntax, right? Now, every time I run this program, every time it will give me an error. Even if I run this program 10 times, this program will keep giving me an error because error is a mistake. This is a compile time error. This is a mistake. My program will not run only. But now over here, the problem with this program, now made that correction. So the problem with this program is now logical. The problem is not syntactical. Now when I run this program, when the values are fine, the program is working fine. When the values that I give and the third value for the divisor, so the value of C, if I give as 0, this program is not working. So this is an exception. So exceptions are those cases for which the program which otherwise runs fine is not working. Now that is what is an exception. Exception handling. Exception handling is basically the set of strategies that we are required to implement to ensure that my programs do not get stuck up abruptly. The worst thing that can happen to your program is that your program terminates abruptly, right? If your program doesn't start, I'm okay with it, right? But I don't want my program to just keep executing and then suddenly it abruptly stops. That is something which should not happen. So every programming language gives us certain strategies or certain methods using which we can take care of this. I don't want the program to start abruptly, to stop abruptly. Just in case my program faces something like this, we should be able to handle it, and we need to design a strategy for that. Now, that is what we are going to learn under exception handling. Now, For tackling these exceptions or for implementing this exception handling, our system provides two words, two terms, try and except. Now, try kya hota hai and except kya hota hai, you need to understand this properly. Now, just look at this particular code. Please dhyan se dekhenge. I'll first give you what is the meaning of try. Then we'll give you what is the meaning of except, and then we go ahead with our discussion. See, I've added something like try over here, and I have added something like except over here. So let us first try and understand what is the purpose of this word try, what exactly it does. How do I decide where to write try in my program? Then we'll talk about what exactly is except and what is the communication that happens between try and except, right? I'll come back to the program later. Let us first try and understand the role of this try block. Now, what exactly is the role of this try block? See, the behavior of this try block, is exactly the same as apna traffic havaldar. You might have seen this guy at so many places, right? Now, understand what is the role of this traffic policeman. Now, first and foremost, this traffic policeman, he will go and stand at a place where somebody is likely to violate some traffic rules. Imagine this fellow goes and stands at a place when nobody is violating or nobody can violate any traffic rules. In that case, there's no point. He'll just keep standing. Udhar khade reh ke uska time hi waste hone wala hai. Nothing is going to happen. So first thing is, he will position himself very smartly. He will go and stand at a place where he'll go and stand at a place where there are chances that people might violate traffic rules. Then what he'll do is, he'll keep an eye on the traffic. See, everybody who is following the traffic rules, he'll keep an eye, but he will not interfere with that working. He doesn't interfere with everyone and anyone who's driving on those roads. No, he will just keep an eye. He will be there, but he would be passive. But now suppose somebody violates some traffic rules. Suppose somebody is now jumping a signal, right? Suppose a bike wala hai, that fellow has just jumped that signal. Now suddenly what he'll do is, as soon as there is someone who has violated traffic rules, this fellow will go ahead and catch hold of that person. Usko pakad lega ye. If you ask me, what is this traffic guy doing on the roads? I'll say he's doing exception handling. Now, why I say that he's doing exception handling? This is because most people, when they are driving, they will follow traffic rules, but there are certain exceptions on those roads who do not follow traffic rules. This person, he is responsible for catching hold of those guys. Now, what this fellow will do is, this fellow will catch hold of these people who are not following those rules, and then he will take them to someone superior. You would have always seen that this traffic guy always has another superior with him when he's working. So what this fellow will do is, this fellow will catch hold of someone who's not following the rules and then take him to that superior. Now, the role of the superior officer is the same as that of your except block. So once this try blocks take someone to this except block, try block will tell the except block that this fellow has done this, and accordingly except block will then take the necessary action against that particular statement. So in simplest possible terms, what is try going to do? Try will catch hold of exceptions, and second, it will report it to except. Then this except block, when interrupted by the try block, will then take the necessary action against that particular exception. So that is what it will be doing. So now look at the statement again. Now observe this very carefully. Where have I written try and catch blocks? Observe. Sorry, try and except block. Now understand this, please. See, I could have put this entire program inside try, possible. But understand, it shouldn't be that you should be writing everything inside a try block. See, the reason is, if there are statements where there is no chance of an exception to be generated, if you are putting that under try block, then you are unnecessarily adding work for the system, which is not advisable. What I find is, I have read some values of A, B, and C. My problem begins in this statement. If the value of C becomes 0, that is where the problem begins. And then if the C ka value has some issues, so I'll not get this value of D. And then in this print statement, I want to use the value of D. So I realize that my problems is the problem that can occur is in these two statements. That is why, if you see, I have written only these two statements in this try block. So only those statements which are likely to generate exceptions, we will be writing those under this try block. Now observe this. Suppose if this program is working fine, let me take different examples. Suppose the value of A is 5, the value of B is 7, and value of C is 2. Now I'll come over here. Now understand, this try block is continuously keeping an eye on these statements. It'll keep checking. So this becomes 5 plus 7 diff 2. So everything is proper. No exception was generated. So this program will execute like a normal program. Understand, try and except statement, even if you have it in your programs, they will not interfere with the working of your program unless and until the exception is generated. Like suppose if I'm driving on the road, I am following all the traffic rules properly. Even though I have that traffic policeman standing on the road, he will not interfere with my working. He has no role to play unless and until I play some mischief. He will not interfere with my working. Same here. Unless my program generates an exception, this try and except block will not interfere in working of my program. Now, suppose it goes like this. You've given the value of A as 5, you've given the value of B as 7, and you've given the value of C as 0. Now when I go to this try block, so this becomes 5 plus 7 div 0. Now as soon as this becomes 0, this try block sees that, okay, an exception has been generated. What it will do is it will stop the program here and immediately it will invoke this except block. It will send a message to this except block. Now there are so many different kinds of exceptions that that can be generated. Over here, we've just taken one example, which is say a zero division error. This exception that is getting generated is a zero division error. A zero division error is an exception which is identified by my system by default. So over here, as soon as zero division error is generated, this except block gets invoked and then it will display denominator is 0. So what you will find in this program is whenever the denominator becomes 0, this program will generate the denominator is 0 exception. So what does try do? Try will catch hold of an exception as and when it is generated. What it will do if the exception is generated, it will take that exception and it will report it to the except block. What will the except block do? This except block, when invoked, will go ahead and take the necessary action against that exception. Now observe this. I'll run this program with the try and except block. Now when I run this, it is asking for 3 numbers. Suppose if I give the numbers properly, 5, 6, 9, all is good, I'll get my answer. So absolutely no issues over here. It has executed like my normal program. But observe this. Now when I go here, this is 5, this is 7, and say the value of C is 0. Now say it is saying denominator is 0. Understand, now I am controlling what happens when the exception is generated. Previously, when you saw when I was running this program, whenever the error was whenever I was giving the denominator as 0, the program was terminating abruptly. You saw a lot of errors over here. So it was terminating abruptly. Now that does not happen over here. So today, after we write programs, it is mandatory that we have to make sure that our programs do not have exceptions, because we do not want the program to get terminated or to get hampered by abrupt termination. That is something which is not needed. Now, zero division error is actually a class which is there in Python, which is predefined. So depending on what are the kind of exceptions that you want to capture, you will have to mention the respective error over here. Try and except, right? Now in the program that you have just typed, just add try and except, try and execute this program, get the outputs, and then we continue. General exceptions. Suppose if I want to capture an exception without knowing what that exception is, then how do we do that? In the previous program, we saw in the except block, we were writing whatever is the name of the exception. But if I write just try and if I write just except without writing the name of the exception, whatever exception gets generated in this code that I've written under try, this except accordingly, that exception will get captured. So that is how you can generate that is how you can capture generalized exception. So don't bother that, okay, what if I don't know what is the exception that will get generated, how will I capture it? You'll still be able to do it, right? Whatever code you've just typed, just modify it in less than a minute, get this output, and hopefully it should work, and then we go to the next program. user defined exception. Now this is something which is really important for us. User defined exception, ye kya hota hai? See, if I talk of my exception handling techniques, now if you look at this program that we just wrote, this program is capturing only one exception, which is zero division error. So whenever in this division operation, if the denominator is zero, it generates a zero division error, right? Now this scene that where the denominator becomes zero is identified by your Python system. Python system has already defined this, identified this case, and whenever that happens, it will generate an exception. Now over here, if I'm entering an integer, I'm expected to enter an integer, but instead of an integer, if I enter say some character value, if I enter say R as my input over here, right? If I enter say R as my input, this will still generate an exception. So Python has already identified so many scenarios. If they come up in your program, that is when it will start generating exceptions. But what if I want to write a code wherein I want to identify, okay, that this is the unique case in my program and I want to generate an exception for this particular case. मतलब मेरे को अपनी मर्जी के किसी भी केस के लिए एक्सेप्शन जनरेट करना है. या आप ऐसे समझिए, I want to generate an exception for a case which is not identified as an exception by default by Python. पाइथन जिसको बाय डिफॉल्ट एक्सेप्शन नहीं मानता, उसके लिए हम एक्सेप्शन कैसे जनरेट कर सकते हैं? यूजर डिफाइंड एक्सेप्शन. Also, see this zero division error, this particular class that I'm using over here, this is a built-in class by Python. Now you will see that I can actually create my own classes for exception handling. So अब जो program आपके सामने आएगा, in this program, not only will I generate an exception for a case that is defined by my program or which is specific to my program, but I'm also going to use a class which is created by me. So I'm not going to rely on Python at all for exception handling. Now I will do it for my own case. Now over here, we've taken a simple example. We need to generate a custom exception for values entered outside the range of 10 to 20. Now, suppose I have a situation where I want to accept some value, say for variable, say A. If the value of this variable A is in the range of 10 to 20, I'm okay with it. But if the value is say less than 10, or if the value is say greater than less than 10 or value is greater than 20, then I'm not interested. Then I want an exception to be generated. Now, how do we do this? Now understand, this is the custom requirement of my program. Only if the value is between 10 to 20, I'm going to accept that value. If the value is less than 10 or if the value is greater than 20, I'm not interested in accepting those values, but I need to generate an exception. Obviously, the Python system doesn't know the custom requirement of my program. So now we'll see how can we actually generate it. Please look at this. Now look at this very, very, very carefully. What am I trying to do? Now, over here, now look at one class at a time. I've created this class called myException, which is derived from class exception. If you remember, this is the concept of inheritance, which we've discussed as part of object-oriented programming. So over here, I've derived this class myException1 as a derived class from this class exception. Whenever you want to create a class, your own class for exception handling, you will have to derive that class from this class called exception. Now inside this class, I have written an initialize method. Initialize method, you know, is kind of constructor. When does initialize method get executed? And initialize method will always get executed by default whenever we come to this particular class. So over here, this initialize method will get executed and we'll say my exception1 is raised. Similarly, I've created another exception class, say exception, another class exception2, which is also derived from class exception. And this also has another initialize method, which will say my exception2 is raised. So precisely, if you look at my code over here, what I've done is I've just written two separate classes. Okay, okay, I'll just segregate them a bit. Let's see if that helps. Now observe. So I have one class, which is my exception1. Then I have, this is my second class. And then this is where my program starts. So actually this program has three parts now. I have two classes and then I have this rest of the code. So I've derived two classes, my exception one and my exception two from this particular class called exception, and then I've added constructors. Now observe this. I'll ask you, enter a number between 10 and 20. I'm asking you to enter a number between 10 and 20. Suppose the number that you have given me is say 6. Sorry, 10 and 20. So let me take it as 16. Suppose the number given is 16. Let's see what happens over here. Now this is where my try block is, right? Now when I write try, if n is less than 16, if n is less than 10, I'm just checking whether the value is less than 10. 16 less than 10 is false. So this is false. So this does not get executed. Then I go here. If this is false, then I come to this elif. N is 16. 16 greater than 20 is also false. So if this is false, this also does not get executed. I'll come out and I'll execute this finally block, and it will print done on your screen. But now look at this. Suppose it happens that you give me the value of n as say 5, right? So what I do here is I'll go here. I'll start with this try block. Now this is 5. 5 less than 10 is true. This is true. So over here, I'm now invoking that class on my own. Raise my exception. So using this raise command, I'm calling my own class, my exception one. What is my exception one? My exception one is this class. This class will get invoked. As soon as I invoke this statement will execute, and it will say my exception one is raised. So over here, I've generated an exception for my own case using a class which we have defined on our own. Now, suppose the value of n, say, was 25. Then when I go here in this try block, 25 less than 10 is false. This is false, so this does not execute. So I come to this elif. This is 25. 25 greater than 20 is true. Raise my exception to. It will go and it will invoke this particular class. Now my exception to this will get executed, and it will say my exception to is raised. So this is how my program is going to work. So over here, what we saw is that I can generate exceptions for our own cases by defining our own class. So it's very simple. How do you define a class for exception handling? You'll have to define a class like this, which will be derived from class exception, and all you need to do is add a constructor inside it, and it's fine. So I can literally create an exception for anything that I want in my program. Not necessarily I rely only on the tools which are given by Python. So this is how we'll implement user-defined exceptions in Python. Right? You can type this, get the outputs quickly, and then we discuss this.
Sorry, this finally.
Okay, so this is how we can generate exceptions. We can capture exceptions which are already defined in the system, and we can generate our own classes for exception handling. Though a small concept, but you will be needing it when you implement a lot of concepts in Python, just to ensure that the program does not terminate abruptly. So that is what is exception handling, and that is what is the end of this particular session.